Good morning, guys. How are you? I hope that you're all doing well. It's been a while since I've gotten to talk to you. I apologize. I hope that you guys are doing really well with the mental health stuff. Please let me know if you're not. There's always people to talk to. I'm not a registered psychiatrist, but I can listen. I do have ears. So just let me know if you need anything. Let me know if you need help, and that sort of thing. And we'll do the best we can. Okay? But I hope you guys are doing well with that. A couple of announcements. Let's talk about office hours first. Office hours. Office hours have been a little hit or miss with me, and I apologize that a few of them I've had to miss, and a few of them we haven't had, or whatever the case may be. Listen, guys, I want you to understand something with office hours. It's really entirely up to you. I just turn it on because I'm sitting here at the computer. Okay, so please stop by if you want to say hey. Stop by if you have questions. If you're concerned about your grade, anything like that, you can always stop by office hours, okay? And we can, totally have a conversation or whatever the case may be. And if we can't do it at office hours, like if I didn't have office hours or if you didn't make it, we can always do it, another meet, with your parents or something like that, or another teacher so that we can make sure that, we got you caught up and got your questions answered and all that stuff, okay? Another announcement. So we're going to be wrapping up Play Tectonics today. Basically wrapping up the chapter. This will be the last PowerPoint. Okay, so we'll go through this PowerPoint. I want you to pay attention to the Ed puzzle because the Ed puzzle is going to count this time. You understand? I'm dead serious. Please make sure that you are answering the questions correctly to the best of your knowledge. Okay? Use your phones. Hello? That type of thing. But I want to see correct answers on the Ed puzzle, so you better be either make sure you're paying attention to the video and make sure you know some of the past stuff that we've done. Okay? Because I want to have, we're going to have a test this Friday. So you'll get this assignment today, another assignment tomorrow, then we'll do a study guide, we'll try to review on Thursday, and then we'll try to have a Friday test. Okay? It'll be your first test. It'll be multiple choice, just like always. Nothing out of the ordinary. Okay? So be ready for that. I think that's pretty much it. So let's dive in here. Okay. All right. So the last time we left off, we were talking about plate boundaries. Okay, and we talked about the three types of plate boundaries. Three types of plate boundaries. There are convergent, transform, and divergent. You guys can see them right here. If you can see my mouse, I'll click on it there for a second. Okay. So you can see right here you have a transform boundary. These are sliding past each other. Divergent means they're going apart, and convergent means they're coming together. And convergent usually means there's some kind of subducting plate. It can be oceanic continental, continental oceanic, and each one depends on what it creates. Okay, you can see that this convergence is making a trench. Now, something we're going to talk about today is we're going to talk about actions at plate boundaries. Okay, so make sure that you know those actions. All right. Now, plate boundaries, we just did it, divergent, convergent, transform. Divergent moves apart. The most popular divergent boundary that you can possibly imagine is mid-ocean ridge. Okay, that's how we found out about seafloor spreading. Then you have a convergent boundary, which moves together, coming together. Usually one subducts. If you get the subducting, you get, a trench. Okay, and then also they can come together and they can get a subducting, but you can get a push. And this push right here can make mountains. Okay, so you can get mountain ranges and things like that. And you're going to see today like how mountain ranges are created at convergent boundaries. Okay, and then you have transform. Transform boundaries are when they move side to side. San Andreas Fault in California is an example of a transform boundary, which is why they have earthquakes a lot and things like that. Okay? All right, so let's talk about these actions. Okay, so let's talk about convergent first because convergent has multiple things going on at them. Okay, and depending on what type of convergent it is, may depend on that. So, at convergence, first things first, you have a subduction zone. It occurs when one oceanic plate is forced down into the mantle beneath the second plate. Now, this is a result of what? Density. That's right, one plate is less dense than the other. Okay, or is more dense than the other, so it subducts, Okay, and so it subducts under. And when it subducts under, you get mountain ranges, you get hot spots, you get island arcs, you get all kinds of different types of actions. Now, let's go through these actions. Now, here's one. Now, this is the Andes Mountains. Okay, now the Andes runs up the coast of South America and Chile. Okay, and the Andes is the longest mountain range in the world. It was created by a convergent boundary, and you guys will see in the map in just a second. It's part of the Ring of Fire. Okay, but this was created by a convergent boundary that's subducting at the coast, and then it's creating mountains on the other side. Okay, so oceanic continental, you have a denser oceanic slab, so the slab that's actually under the ocean is sinking into the asthenosphere. So these pockets of magma develop and rise. They form continental volcanoes, Andes, Cascades, and Sierra Nevadas. Okay, so right here, sorry, my mouse is a little touchy this morning, apparently. Okay, so if you look right here, here's what's going on. So you have the oceanic plate subducting underneath the continental plate. Okay, here's your trench that's being formed, and here's your volcano island arc right here. Okay, your volcano arc, because this is creating these hot spots. Okay, and making these volcanoes. All right, and here you can see the Ring of Fire. So here's what is happening on most of these convergent boundaries right here. You're getting trenches and you're getting volcanoes. Okay, you remember Marianas Trench is right here. Okay, here's South America. This is California over here. Don't get this confused, because this is the Pacific. Okay, all right. So let's talk about oceanic. So that means that the two plates are converging underneath the ocean. Okay, all right. So whenever this happens, you're going to get volcanoes forming, but you're also going to get islands forming. This is how Hawaii is formed. Okay, and with these, you can kind of see. Okay, so here's your subducting plate. Okay, here's your trench, and see these hot spots. These hot spots are creating volcanoes, and volcanoes create islands. Okay, and that's how the oceanic works. And then we're going to do a continental. Continental is going to be massive mountain ranges, like the Himalayas and places like that. Okay, so here's what's happening here. You've got one subducting. Here's the one continental plate. I don't know why this says oceanic, because it's not oceanic. But you have one continental plate going under. You have one continental plate coming together. And as these are coming together, you can kind of see that's creating this mountain range right there in the middle. Okay, and here's like the collision of India and Asia. Like, this is basically based on Pangea and seafloor spreading and how this kind of happened. So India used to be way down here 71 million years ago, and then it kind of moved up, and it collided. And you guys, if you guys can see my mouse right here, you see this little line right here, and I'm going to show you a picture of this. It kind of created this really interesting mountain range. Okay, and so you can kind of see here how this kind of came together. All right, and so this is in Wyoming. This is like where you have older crust in the middle and lighter crust outside. Okay, all right. So with that being said, at convergent boundaries. Okay, now at divergent boundaries, we already know Mid-Atlantic Ridge creates a volcano, seafloor spreading. We're going to get to that. Okay, now the important thing to remember about divergent boundaries is it is the main thing that we found out about paleomagnetism. Okay, because of seafloor spreading, and I'm going to show you that in just a second. So paleomagnetism is basically the magnetism between rock bodies. Okay, so all the rock that's underneath our that's in the ground, okay, is magnetized to a certain extent. Okay, and our Earth is magnetized, and I think you guys know that. We have a North Pole, we have the South Pole, the opposites repel. Okay, all those things. All right, and our magnetic field, we've already talked about a little bit about when we did the atmosphere, because it controls a lot of what comes into our atmosphere and things, so we talked about it. Okay, and here's just some pictures of kind of what our magnetic field looks like and how it kind of draws in. Okay, all right, so you have this normal polarity. So normal polarity is when rocks show the same magnetism as the present magnetic field. Okay, and then a reverse polarity is when the rocks show a different or opposite magnetism as the present magnetism field. Okay, now so we discovered this through seafloor spreading, because we discovered strips of alternating polarity, and when they discovered these strips of alternating polarity, they're like, oh, okay, well, what's this? Okay, now this is probably or is the strongest evidence for seafloor spreading, because that if you look at this, now if you look at these, each one, so let's say the black is positive and the white is negative. Well, if you look at this, then how, other than seafloor spreading, then magma coming up through here and actually spreading this apart, you can see the different polarities going across. Okay, all right. Here's what it was like, an actual like kind of view. Here you can see the black is like normal polarity, and you can see the white would be reverse polarity. Okay, where they're actually repelling. Okay, all right. Here it is over time. Okay, so over time, here's the mid-ocean ridge. You got magma coming up. Magma seeps out, creates new rock. Okay, this new rock, then it just creates a new process, but it's got a different polarity. And so every time it's got a different polarity, you get these streaks. Okay, and we have these streaks in our rock down there. Okay, all right. So divergent boundaries, you have, it's a very, very big deal as far as paleomagnetism, because the divergent boundary at the mid-ocean ridge is how we kind of prove seafloor spreading with paleomagnetism. Okay? All right, so with earthquake patterns, scientists found a close link between deep focus earthquake and ocean trenches. Okay, so ocean trenches and things like that, because that convergent boundary, remember that massive tsunami that hit Sri Lanka, remember that was subducting, and it popped. And when it popped, creates a massive tsunami. Okay, let's talk about ocean drilling for a second. Ocean drilling is done out in the ocean. You guys know it's where we get oil. You guys remember the BP oil spill? Now, this is basically saying that most, the easiest places to drill is out in the ocean, because that's the youngest oceanic crust. Okay, the youngest oceanic crust is out in the ocean because that seafloor spreading is creating new crust. So at the ridge would be the youngest place, the easiest place to drill. Whereas like along the continental margin is going to be the oldest, probably harder to drill in those areas. Okay, but ocean drilling is very important. We get a lot of resources from the ocean, so it's good to know things like that the continental margins are the oldest rock. Okay. I'm pretty sure this is the last slide, but let's talk about hotspots for a second. Hotspots are created, whenever you have those convergent boundaries coming together, one's going underneath the other, and you get those hotspots. It can create an island arc, it can create volcanoes, it can create lots and lots of different actions at a plate boundary. Okay, so make sure that you know what hotspots are. Do not misconstrue, like, you guys did okay on, like, I'm still going through a lot of the quizzes, but like on the quiz, you guys had to tell me, the difference between like rift valleys and like the characteristics at plates. Okay, so now that you know the actions and you have the characteristic at plates, now you kind of know what plate tectonics is and like how they operate, and you have a gist of it. Okay, but these hotspots are how we create a lot of our volcanoes and new mountain ranges and things like that. The Hawaiian Islands was created by hotspots. Okay, so you can kind of see this one. Okay, see this hotspot that's actually popping up right here. Okay. All right, guys. So, like I said, it was pretty short and sweet. There really wasn't a lot on this PowerPoint today, so please make sure that you're watching the video all the way through. Don't forget that the Ed puzzle counts this time. Whatever your score is the score that you will get. Okay, I apologize for those. Remember that the questions that do have more than one answer, you have to select all of the correct answers. Okay, not just one. Okay, so if it's like a 4-part question, you have to select all 4 parts. Okay, all right, has everybody got that? I hope you are all doing well. Please get in touch with me if you're not. Please get in touch with me if you're having trouble. Guys, listen, some people, like if you've got friends that aren't logging in and things like that and not doing anything, we need to get in touch with these people and get them in, because there's about a handful of people that just aren't doing anything, and I worry about them. So let me know if you guys know anybody that's not doing anything, or if you know somebody or if you're watching this and you haven't done anything, do your work. Like, look, do I think they're going to be super strict on this stuff? Probably not, because this is all new to all of us, but I don't think they're just going to let you do nothing. So, good luck. And we got perfect timing because V's just waking up. Sorry if you can hear her. But guys, listen, I hope you're all well. I miss you like crazy. I hate that we're not going to get to see each other the rest of the year, but hey, I'm here. Email me if you need me. We'll do office hours, swing by office hours, and let me know if you need anything. Hope you're all well. Take it easy. Toodaloo.